All right. Well, I'm going to go and segue right into our third topic right now, our ECL Tech Tip of the Month. All the T's involved here. I was calling it a tiny trove of table tidbits. So just like last month, I kind of made our team a little bit hungry last month. I was talking about the tech tips being like a 3-course meal, and I said that the tech tip is kind of like the dessert. And yeah, this is a light dessert today. This is we're just going to talk about things that some of you may already know, some of you don't know. Just kind of pulls it all together as far as what the table can do. So let's get started with this. My first poll question, see how much you know about the table function. What is a practical use of the table function? So go ahead and take a crack at that poll question, see what we answer, and then we'll review that at the end of this. So I've been working with ECL now for a little over 8 years, and my colleague Richard Taylor, of course, my mentor, manager, he's been working with ECL since day one. And, we had a discussion about this tech talk, and he was telling me that the table function was one of the original primitives that came out with ECL, one of the first statements available. Came out before all of the transforms became available, the project and the iterate and everything else. So table has been around for a long time and continues to exist in the ECL language. And I'll tell you why I wanted to get into that a little bit. So in summary, some of the many things that it can do, I'm just going to highlight the 4 really big ones. Table can be used to expand an existing record set, taking a record set of fields and adding new fields to enhance your record set, add more fields so that you can add more value to the available data that you're already working with. The second use is reducing. Sometimes, again, one of our fundamentals of ETL is to work only on the data that you need. So a table is a great way of reducing a record set size of fields from, say, 20 fields into maybe 10 fields that are only important to you. Third use is transformation or standardization of an existing record set. This is something that we teach in our Introduction to ETL Part 2 class as we go through the ETL process. I first saw this when our Chief Data Scientist, David Bayless, introduced it in one of his online tutorials. He was talking about using a table to do data transformation. And I'll show you the code example of that as we get into the slides. And the last one, of course, is the one that I think everybody should know about or everyone uses. And it's such an important way of profiling data and analyzing data and seeing what you've got ahead of you. Of course, I'm talking about the cross-tabulation, or what some people call the group by reports. So here's kind of a short version of the table function, kind of condensed a little bit, some of the fundamentals. When you build a table, you start with your source, which is the record set parameter, the very first parameter of the table. The second parameter of the table, which is always required, of course, is the format of the output of the table. So once again, you can have a record structure that is larger than your original data set, or you can have a table structure that is smaller than your original record set. And of course, one of the rules that we teach all of our people in class, we say all the fields in the record structure must use default values, because we're accessing, of course, memory directly. We need to have something in there, especially if you're adding new fields that weren't part of the original source. So you have these new fields. You don't want garbage to be in there. You want to initialize them. Even if the initialization for numerics is 0, that is a default value. And for your string fields in the table, the default value is a blank. So then we have our group by clause, the expression parameter, which is shown here as an option, yes, because some crosstab reports like min and max and sums and averages can actually do their crosstab on the entire file. So if you don't need a group break, you can actually eliminate it from your table. And of course, if you're not using crosstab reports, you don't really need a group by clause as well. So that is the expression parameter. And then there's some other different features of the table that enhance the performance and the operation of it. If you're working with less than 10,000 distinct groups, you can add the few attributes to the table, many attributes to the table. Local, we're going to talk about local, and also another one that's not on this slide called merge. So I'm going to mention that in the slide coming up here. So the fundamentals of tables are simple. Here's an example of just building a slice of a larger record set. We have this table statement down below that's referencing the person's record set, the record structure itself. Notice no third parameter required because it's simply reducing. So it's going from a larger person's record set down to a smaller three-field table. Also, the vertical slice can be expanded. And here's the thing I was telling you about, where you can have new fields added to your table. And sometimes you don't have a distinct value for it yet. You're going to be adding that later. So you do have to initialize it to some kind of default value. So you see here, the sequencing field is defaulted to 0, and the string field is defaulted to Bob. All right, so one of my slides here, this is my friend, my colleague Dan Camper, who put this slide together. I thought it was kind of cool, so I wanted to share it with all of you. He talks about table being used to do aggregation, of course. And he mentions that table is the most commonly used data aggregation function in ECL. And there's a review of the parameters again that we illustrated in the previous slide, the output record definition, and so on. And in the output record definition, when you're using aggregation, the trick to crosstab reports is not the third parameter of the table, but the group keyword that's used inside of the record structure of the table that you're building. And inside that group keyword, the group keyword can be used in any of the 8 aggregate functions that we have available, being sum, max, min, count, average, variance, covariance, and correlation. The last 3 being statistical functions. Then we have our grouping conditions. We talk about how you can specify multiple groups of multiple fields by just separating them by commas. And then here's the flags that I was mentioning. We have a couple of flags that a lot of people they are not aware of or they don't use, but I'm going to share with you an important tip here. With this is really the tech tip of the month here, talking about merge and local. We had an email from a good colleague of mine, David Wheelock and Richard Taylor. They were chatting about something, and they were talking about mentioning the use of merge as a way to do grouping when your group function creates subgroups that are too large to fit into memory on a single node. So again, sometimes table with the merge attribute is a workaround or a better solution, more efficient solution than just using the group function alone. And so, of course, why do we group? Well, of course, some operations like dedupe and all require that the record set be grouped in order for efficient operation. We like to say that sometimes, it's more efficient for the compiler to work with 10 groups of 1 million records instead of one group of 10 million records. So the use of merge, the use of local is mentioned here in this slide, and it's pretty much a good tech tip that if you're having trouble using the standard group function, that you can use table with merge instead. Table with local is very similar to merge, except it doesn't correlate everything at the end of it. And I just had a code example I was looking at this morning that actually illustrated that point perfectly. It leaves everything on the same node and doesn't correlate things together by their grouping, where merge does use the grouping to pull them together. So in a simple test I ran, my local table had 5 results, 5 records on it that was groups on each node, and then the merge merged the common groups into a single entry, and so my merge result only had 3 results, which was really interesting. All right, so let's take this home now. We'll wrap this up with some code examples. We have our group keyword that's used in crosstab reports. There it is right there in this record structure. So in this crosstab report, we are doing a crosstab report first by state and then by gender. So how many males do we have in the state of Alaska? How many females do we have in the state of Alaska? And so on. On each break of gender and state, we will have a count of how many records we have in each group. Here's another crosstab example. Again, just a count by state, so we don't need to overkill this. Let's go to the next slide. This is one of David Bayless's original examples from his tutorial. Notice at the top of this slide, you've got just one long string of information for each record. You've got a book of the Bible, chapter, verse, and then the actual text itself. And David here uses a table to not only parse out the information, but also transform the information at the same time. He's got a couple of local functions up at the top of the record there, get chapter and get verse, that's just doing some string parsing into that line. And then he applies that function inside of the table. He initializes book number to 0 because there is no book number in the original input record. And then he's using the rest of the information, the parsing of the verse information, starting at a particular position in the string using the find function and then parsing out to the end of the string. Builds a table, and the output looks something like this. So again, at the top, that was the input data, goes through the transformation of the table. The output at the bottom here splits it out into 5 separate fields, and everything is converted properly. So table can be used as a transforming tool. Again, here's something we show in our classes. Here we have a person's record set that we are applying to a table, and inside the record set we are uppercasing our 4 strings, first name, last name, middle name, and suffix. We're standardizing that. We're also standardizing the date, converting the original string 8 format of this person's record set into unsigned 4s. And the beautiful thing about that is unsigned 4s, then we can take advantage of the many, many date and time functions that are in the standard function library. Notice also we're exporting this, wrapping it inside of a module, and actually calling the table a file and persisting it. So yes, you know, tables are only created in memory, and when the code is finished, the area of memory is then cleared. So if you want to continue to use this as you're moving forward in your transformation process of data, you can just save this as a file, quote unquote file. And so to reference this table information, I would reference std_persons dot file, which the table function being persisted, then this will perform much faster, and will be the persist file in general will be up to date. All right, so that's the output of the table. You can see the string information here of the names being uppercased. And just one more before we open for questions here. I like this one because this was written by my colleague Dan Camper, so props out to you, Dan. This was just a simple way of doing an inline crosstab report. I thought it was just kind of cool because as an ECL developer, I think the mantra of many of you out there is, I don't like to type. So this is a way of simplifying it. You can see he's creating a table with a crosstab report, but the record structure is inline. So he's reading the person data, he's outputting a zip code field, and then doing a count by the people in that zip code, breaking on zip code, and you see he's using the merge attribute, the merge flag in the table to improve the performance of the crosstab. So everyone give that a try. Try merge and see how it affects your performance. I'd love to hear back from you how it works for you. All right, so that's pretty much my overview of the table. I'm going to check the questions first, but I do have something to say about, table versus project. So we'll get to that when we get to the Q&A. Our last question here is, what is your primary use of the table function? So let's take a look at that. first of all, let me see how our poll question worked for the very first question. All right, so the first question was, what is the practical use of the table function? Only 5% of you said you expand a record set. Only 11% said reducing a record set. Nobody standardized a record set. Okay, nobody used transformation using a table. That's very interesting. Most of you use it for cross-tab reports. Oh, of course. Well, I forgot my fifth choice, all of the above. Almost half of you use all of these first four uses. So that's good. That's good. All right. I was a little worried because I saw 0% only using tables to standardize, but then I see that 47% use all of the above. All right. So let's take some questions from the audience. Let's take a look here. All right. Is table a function or a language construct? All right. Well, it is technically in the language reference manual a function. You'll see in the documentation it is a function, table function. It returns a value. It returns a record set. Just like the project is a function, the iterate is the function. They all are functions returning record sets. Is there any advantage of using table over project regarding performance? Thank you for forwarding that slide, our producer. All right, is there any advantage of using table over project regarding performance? I don't think so. I've run a lot of tests on this, and I think it's more a matter of style than performance. And remember, I said what came first? Table came first over project. Project and iterate and all these other guys were introduced a lot later on. So I look at it this way. I look at, first of all, in a project, you have a transform structure. And what can a transform structure do that a table can't do? And the answer is, well, a transform structure can skip. And if you guys haven't seen Gavin Halliday's blog on the HPCC Systems website, please check it out. Gavin talks about the use of skip in a transform and advantages and disadvantages of using it. And so, yes, you can skip records in a transform based on a conditional expression, which is kind of cool. I don't think a table can do that. The other thing that I think is handy is in a project's transform, or any transform for that matter, you can include local definitions, local attributes. So you can encapsulate them in the transform function so they get declared for every instance that the transform structure is getting called. And then, of course, in the table, what you see is what you get in the record structure. What you declare in the record structure is actually output. So I see a couple of coding advantages of using project sometimes, but I would say that performance-wise, they're pretty much the same. Are there any constraints on the size of the table, for example, memory space? Well, I believe in HPCC what happens is, everything works in RAM. And, of course, if you run out of RAM on a particular node, it will do a disk spill. So other than running out of disk space on the node, I mean, that you could have an out-of-memory crash, maybe something to that effect. But I believe the table will try to work in the available RAM that it has. It runs out of memory in RAM. It will spill out the disk. So I know really of no limitations other than the limitations of the, disk space and memory of the node. Might be wrong in that sense. Somebody might want to chime in on that later and correct me on that. But I think as far as I'm concerned, there's really no limitation to the size of the table. All right. Once again, thank you. It's a truly terrific Tech Talk tip about the table tidbit. Is more information available in documentation? Absolutely. That's where most of the information I got came from, was the documentation. Okay, I've already answered the table versus project. Let's see what else. We can perform most of the functionality what table does with the project. Is there a transform or project functionality used at the back end and making it easier for the user? Is there a transform or project functionality used at the back end? Like I said, not really. I think I mentioned some of the things that you can do in the project that you can't do with the table. So, again, I think it's a matter of style. And if you wanted to skip records as you were projecting, you could use that inside of your transform function. Is it necessary to delete the persisted table explicitly? If so, how to delete the persisted table? Oh, all right. Well, Well, again, the way the persist works, whoever asked that question, is that it will always persist. You can expire, at the end of the day, you can specify an expiration time of the file so that it will automatically rebuild. But generally, if the underlying code, the C++ that's generated by the ECL IDE, the compiler, or the data has changed, then persist will automatically change. So it's one of those things you kind of set it and forget it. There's no need to delete the persisted table. It will remain current until either the code or data changes or you expire the file. And once you expire the file, then it will automatically rebuild at that particular time. Okay, so I think I've gone through most of the questions there, and as always, you see my email up here, robert.foreman@lexisnexusrisk.com. If you have any follow-up questions or comments, please email me, and we can possibly share that feedback at the next Tech Talk. Let me look at our last poll question here, and let's see what we've got. What is your primary use of the table function? Again, expanding a record set, reducing, and then finally we have 36% saying I use it for all of the above, and we have a good over half of you use it for cross-tabulation reports. And I will say that is kind of the workhorse of table is cross-tab reports. And of course cross-tab reports are so popular. Those of you out there that do it a lot, check out a language statement called distribution. I'll say that again in case you missed it. Check out a language statement called distribution. It's actually an action, and using the parameters of distribution, it actually will generate for you a cross-tab report. The only limitation, which I think is none, is it generates an XML output. So you can actually right-click on the result in the ECL IDE and then save it as an XML file and load it in your favorite XML viewer, and bingo, you've got a crosstab report. The cool thing about distribution is that you could say, give me a crosstab report on every field in my record set. And let's say you have a field like a record ID. Well, of course, a crosstab report on counts, distinct counts, would be kind of silly. So what happens is the distribution action looks at any fields that have too many unique values, and it just kind of stops at 30,000. It says, okay, if you have more than 30,000 distinct values, then I'm just going to quit. So it just tells you that if you have too many distinct values for a crosstab report to be useful. So play around with that. Check that one out, the distribution action. It's actually an action, just like output, and you can use it on any record set. Of course, a lot of you out there have macros that are already built to do crosstab reports. You use them every day. So you just run a macro that just sends in the record set. And once again, Dan Camper, props to Dan Camper. He's got the data patterns that he's worked with that's out there on GitHub that also does cross-tabulation reports, and he actually nests it inside of a data patterns function, profiling function, where you send it the records, the name of the data set, and then any particular field that you want to profile. And again, he produces a brilliant analysis of any incoming data that you're examining. So let's see, there's one more question that came in, I think. Let me just take a look at that one. Great answer for the persist. Thank you, Bob. All right, my pleasure. And you know what? I think I'm come to an end there. So let's wrap this up. So thank you, everybody, for attending. If you have a talk idea for the next episode, a success story, new use case, any kind of application you want to demo, useful ECL tips and sample code, a new suggestion for our roadmap, if you want to be a featured speaker, we have next month, we have Roger Dev. Again, oh, I love Roger Dev. He is our machine learning guru. Don't miss April's Tech Talk. Roger Dev is so good. And then we also have, continuing with our Atlantic Coast Conference ACC theme, where we had Vince today, and next month we have Jeremy Meyer from Clemson, who's going to be giving us a Tech Talk tip. So actually Tech Talk topic. So, all right, that is coming up in April. So everyone, enjoy the rest of your day, and I want to thank you for attending, and we'll see you next month.